Okay, so in this graph, I'm going to do a little review for your quiz on graphing some translations and describing those translations of a trig function from the parent graph. Okay, so the first one is sine. So obviously a very key thing here is knowing what to set your argument between for all 6 trig functions. So we know for sine, cosine, secant, and cosecant, we're going to set that argument between 0 and 2 pi. For tangent, that's going to be negative pi over 2 to pi over 2. And for cotangent, that's going to be 0 to pi. So here we know that this is 0 to 2 pi. So I'm going to take my argument. Make sure you get the entire argument. So that includes this 4. So this whole argument, whatever we're taking the sine of, 4 times x minus pi over 2, less than or equal to 2 pi. Okay, so I'm going to divide the whole thing by 4. So I get 0 is less than or equal to x minus pi over 2 is less than or equal to pi over 2. So I'm going to add pi over 2 to each section of my inequality. And I get pi over 2 is less than or equal to x is less than or equal to pi. So remember, the whole idea is to isolate x so that we can get our new key values that yield the axes values for us, okay, because we know what the value of sine is at all of the axes values. Okay, so now that we have that, we can start making our t-chart. So I'm going to start at pi over 2, and I'm going to go to pi. So halfway between pi over 2 and pi, so remember this is 1, so it's 2 over 2. So 2 over 2 plus 1 over 2 is 3 over 2, and half of 3 over 2 is 3 pi over 4. One thing that I want to point out when you're doing this kind of mental math, no calculator, so mental math, you want to be able to get a common denominator fairly easily in your head, so you may want to make a note. So if I'm going to find the midway between these two, I know that pi over 2 is the same thing as 2 pi over 4. Now I have that common denominator, and it makes it a little bit easier. So I have 2 over 4 plus 3 over 4 is 5 over 4, and then divide that by 2, and I get 5 pi over 8. Okay? I'm going to do the same thing between these two and point out that 4 pi over 4 is the same thing as pi. So I have that common denominator. So 4 pi over 4 plus 3 pi over 4 is 7 pi over 4. And 7 pi over 4 divided by 2 is 7 pi over 8. Now the goal here, as some of you have noticed, is we should be able to replace this entire value of sine, so everything that's here, with that pattern. And that pattern for sine, remember, we find it on the unit circle from 0 to pi over 2 to pi, 3 pi over 2 to 2 pi. So sine of 0 is 0, sine of pi over 2 is 1. Then we go back to 0, negative 1, and then back to 0 again. So what should happen is I should be able to distribute this 2 to each of these values and put it in my chart. Now some of you are relying a little heavily on that, and you're not checking your key values. So then your key values are wrong, so then your ordered pairs are wrong, which tells me that you didn't check it, and then you plot something wrong. There's not a lot of credit as we move through this that I can give you for that because you didn't do any part of the process right. Okay, so you may want to double check, start double checking and ensuring that you are checking those values. So what I would suggest doing is doing 4 times, my first value is pi over 2. Now that's a little obvious, but I'm going to prove my point. So pi over 2 minus pi over 2 is 0, and 4 times 0 is 0. So that's my first axis point. So then I'm going to do 4 times 5 pi over 8 minus pi over 2, which is going to give me 4 times common denominator. Now you don't have to show this, you can do it in your head. 4 pi over 8. And 5 minus 4 is pi over 8. And 4 times pi over 8 is pi over 2. So that's my next axis value. So then I do 4 times 7 pi over 8 minus, 3 pi over 4, minus pi over 2. So that's 4 times 3 pi over 4 minus 2 pi over 4, which gives me 4 times pi over 4, which is just pi. And again, in order, here we go. So that means the next one I should get should be 3 pi over 2. So then I have 4 times 7 pi over 8 minus pi over 2 is 4 times 7 pi over 8 minus 4 pi over 8, which is 4 times 3 pi over 8, which is 3 pi over 2. So again, we're checking out, and the last one I should get is 2 pi. So I have, I'm going to do it right here and erase, 4 times pi minus pi over 2 is 4 times pi over 2, which is that 2 pi. So all of my values check out, and most of you can probably do that with just some mental math, but I very strongly encourage you to get in the habit of checking those key values. So now that I know my key values are solid, I can do the pattern. 2 times 0 is 0, 2 times 1 is 2, 2 times 0 is 0, times negative 1 is negative 2, and then of course 2 times 0 is 0. So another issue that I've noticed is some of you are struggling with where some of these values are. So I encourage you to start with what you know. So you know where pi over 2 is. It's labeled on your graph. So pi over 2 is here. Then we have pi. I know you know where pi is. Well, logically, we did the math, we did the algebra, and we know that 3 pi over 4 is halfway between these two. And it's fairly easy to see halfway between these two. Now, if that doesn't help, if you notice from 0 to pi, it's quartered for you. It's in 4 pieces, pi over 4, 2 pi over 4, 3 pi over 4, and then 4 pi over 4. Okay, and the last thing is this 5 pi over 8 and 7 pi over 8. Now, obviously, if they're halfway between these two, it would have to be halfway here. But just to reconcile that, if this is pi over 4, I don't think you can see that. If this is pi over 4, then this would have to be pi over 8. So every halfway mark, so pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, which makes sense, 6 pi over 8, and 7 pi over 8. Okay? So either way you want to do it, if you want to count it off, if you want to just do a little bit of math, logic goes a long way, remember, in math. So if it's halfway between, I'm up at 2, then I am, sorry, having a little technical problem. So halfway between, I am up at 2, and then halfway between these two, I am down at 2. Okay, so from here, you can use the pattern that you can obviously see here. So every halfway mark, I go from 0 up to 0 down to 0. So I'm going to be at up to 0, down to 0, up to 0, down to 0. Pattern continues, so I go down, up, so I should be down, 0, up, 0, down, 0. And you're going to continue this all the way until you get to negative 2 pi. Okay, and then you can just connect your lines, your dots, sorry. This is not the easiest, I apologize, I know it's not pretty. The last thing that you want to make sure that you do is check that you did the correct amplitude. I noticed on several quizzes, you had it in your chart as 2, but then maybe you went up to 1 or vice versa. So just be super cautious that you're going to the right value. Okay, so for tangent, remember, we're going to set our argument between negative pi over 2 and pi over 2. And we're going to solve for x. I'm going to multiply by 4. So I get negative 2 pi is less than, x is less than 2 pi. So I know when I start to build my chart, see if I can do that slightly better. I'm not sure. I'm not good at straight lines on this. So we have x, y. So at negative 2 pi and 2 pi, and now I'm going to have asymptotes. And I'm going to go ahead and put those in. It just makes it a little bit easier. Okay? So now I know to do my key values, that the first thing I'm going to do is find the halfway between here, which is going to be 0. And then halfway between negative 2 pi and 0 is pi, and halfway between 0 and 2 pi is pi. Now the goal here, again, would be able to do 3 times the pattern minus 2. Okay, and the pattern for tangent, remember, tangent is increasing, so it starts at negative 1, 0 to 1. Again, I strongly urge that you make sure your key values are correct. Okay, so for tangent, I would have 1/4 times negative pi is negative pi over 4. Now we know that negative pi over 4, so we should get out negative pi over 4, 0, and pi over 4. But let's say you don't remember that. Well, negative pi over 4, first of all, you know that tangent of pi over 4 is 1 because cosine and sine have the same value at pi over 4. And if it's negative pi over 4, I'm in the 4th quadrant where sine is going to be negative, which is going to make tangent negative. So it's going to be negative 1. So negative 1. So then I have 1/4 times 0, of course, is 0. So I should expect that. And then 1/4 times pi is that positive pi over 4. So my key values are correct, so I can use the pattern. So 3 times 1 is negative 3, minus 2 is negative 5. 3 times 0 is 0, minus 2 is negative 2. 3 times 1 is 3, minus 2 is 1. Okay, so I'm going to plot those. So I have pi is a positive 1, 0, negative 2, and negative pi, negative 5. Now remember, asymptotic behavior means that function kind of leans into that asymptote. And it kind of has a very stretched out, similar shape as a cubic, so make sure you have some curve to it. Obviously mine is not beautiful, so I'm not expecting perfection. Just I don't want a straight line. So tangent is not a straight line, so just don't make it a straight line. Okay? The last thing is the transformations, the translations. I don't want you to give me the amplitude or give me the period. I want you to tell me how it's changed from the original. Okay, so for this one, we know the first thing that we have to do is factor that 5 out because we cannot see the phase shift unless that 5 is factored out front. So I have 1 minus 3 times cosine of 5 x plus pi over 10. Now, sometimes students struggle with taking that 5 out of a fraction, but it's just divided by, and if that doesn't help, you can always, if you divide it out and you're not sure if you're right, you should be able to re-multiply and get this. So 5 times x is 5x, and 5 pi over 10 reduces to pi over 2. Okay? So the first thing that happens is a plus 1, and it is a plus 1 because it's positive, happening on the outside of the function, which tells me it goes up 1. The next thing that happens is the negative attached to the cosine. So if the 1 was negative, that would just mean down 1. But the negative in front of the cosine tells me that the graph is going to be flipped. The 3 tells me that I have a vertical stretch of 3. Now, if you're not sure, remember that the amplitude of the original graph is 1. The coefficient of the original graph is cosine x, so the coefficient is 1. So if the absolute value of a is bigger than 1, it has to be a stretch because it's been stretched out like a rubber band. It's taller than it was. If the absolute value of a is less than 1, then it's a compression because it's shorter than it was, so it's been compressed down. Okay? So then we have this 5 here. So the 5 is what affects my period. So remember that the original period is 2. You can't see that. So remember that the original period is 2 pi. And that we find the new period by 2 pi over b. So if b is greater than 1, that is going to be a compression. For example, 2 pi over 5 is smaller than 2 pi. So this is going to be a horizontal compression by 5. Okay, if it's bigger than, if b is less than 1, what happens, let's say b is equal to 1/2. So we have 2 pi divided by 1/2. Well, we keep flip change. That's 2 pi times 2 over 1. So it gets bigger. So that's the horizontal stretch. And our very last thing is the x plus 10, which is a phase shift left, inside is opposite, of pi over 10. Okay, if you don't factor the 5 out, your phase shift is going to be wrong. Okay? So again, kind of that same process. A negative 3 tells me down 3. The coefficient of the original graph is 1. Even though a tangent doesn't have an amplitude, it can still be compressed or stretched. And so this is going to be a vertical compression because it's less than 1 of 1 over 4. Then we have this, which is my b, so b is 1/2. So remember, if this would be pi over 1/2, which would be 2 pi, which means a horizontal stretch because the original graph has a period of pi, not 2 pi, so it's been stretched horizontally. So a horizontal stretch by 1/2. And the last thing that we have here is that phase shift. Inside is opposite, left, pi. Now I strongly, strongly encourage you to do all of your transformations from left to right in order. It just keeps you from missing anything, and oftentimes it will keep you from confusing, especially vertical and horizontal. And oftentimes the down and up versus the flipped or not. So I strongly, strongly suggest that you do them from left to right. Now you don't have to. The order is not important as you list transformations, but it, like I said, left to right kind of gives you a pattern to stick by and makes it a little less likely that you'll make some kind of mistake.